we are going to be looking at an NPV problem. Right at the top here, we have the basic NPV equation, where CF0, that's cash flow zero, is always negative because it represents an outflow, the initial investment to set up the project. And these other cash flows we label as summation, cash flow N. Cash flow N means, and whatever N is, N may be 1, 2, 3, 4, 5. In this particular case, N is 4 cash flows of 3,500 each. This is problem number 4, I believe, on tutorial 6. So we spend $10,000 to set up the project, cash flow 0, and the project earns $3,500 each for 4 years. And we have them listed here. This $10,000, you will notice, is not discounted at all. It's just taken at nominal or face value. And that is because it is already a present value. So it can't be discounted because it is money spent now to set up the project. The other cash flows, the other 4, are all future cash flows earned starting next year and the year after and the year after and the year after. So we discount them using the cost of capital, 12%. The first cash flow 1, we discounted 1 year. So we just use 1 plus I, which we see here, becomes 1.12 because I is 12% or 0.12. There's no need to put the bracket and put to the 1 because 1.12 is the same as 1.12 to the 1. The second year, N becomes 2, so we have to put that in now. The third year, N becomes 3, and the fourth year, it becomes 4. So because net present value is a very suggestive name, what it is telling us is that all the cash flows in the project are to be converted to their present values and then netted off. So we have a net present value. The $10,000 investment is already a present value, so we don't trouble that. See, we replace it, we just bring it down here and use it just as it is. The $3,500 for each of the 4 years are all of them future values, which we discount to their present values. So when we come to this line, all the cash flows here are present values. So we have the first part of the equation set up, present value. Then we net them off. So we have this 1 negative, which was the original investment. We have these 4 positives, so we add them together and we get this. So at this stage, we have 2 sums of money. Both of them are present value. One is negative, one is positive. So now, as the name says, we net them off and we get 649. This is for Y. The problem also had an X, so it was 2 projects. You can work that for practice, but you should get 967. Just so NPV Y is 649, which we just worked out and got here. NPV X, which we didn't work out, which you can work out for practice, will give you 967. So net present value is the method we use when we are trying to determine whether we should go ahead or not with a project. But there's also payback. And so using the same Y, project Y, same cash flows, now some differences between payback and net present value are important to understand. Net present value uses all the cash flows. It captures all of them, uses all of them, so we get this holistic view of the project, its costs and its benefits. Payback does not use all of the cash flows, which is a big drawback with payback. As the name suggests, payback is only concerned with the cash flows that are sufficient to pay back the original investment. And so that's one problem. The second problem is that payback does not discount cash flows. It doesn't take account of when the cash flow occurs. So whether it is in year 1 or 2 or 3 or 4, it treats all of them the same way, which is also a terrible weakness because it ignores the time value of money. So here we are with the payback method. We have made the original investment minus 10,000, same cash flow, zero. It's out there. Now we are going to use the earnings, the cash flows earned by the project, to offset the original investment and see when it pays off. So year 1 generated $3,500. We set it off against the original 10,000 investment, and we still have a deficit of 6.5. But we are done with year 1. We reach for year 2's cash flow and we find it to be 3,500 as well. So we set it off against the 6.5 and we still have a deficit of 3,000. So we reach for year 3's cash flow now. So at this point, we have used completely all of year 1 and year 2's cash flows. We reach for year 3 and we find that year 3's cash flow is 3,500. But we don't need all of that. We only need 3,000 to clear off the remainder of the $10,000 original investment. So we only need a portion of year 3's cash flow, not all of it. And that portion is determined, as you see in this equation, by expressing the 3,000 as a proportion of year 3's cash flow. 3,000 divided by 3.5 gives us 6/7. So we only need 6/7 of year 3's cash flow, but we have used all of year 1 and all of year 2. But at this point, with the final 6/7 of year 3's cash flow, we have paid back the original $10,000 investment. So our payback period is 2 full years, year 1 and year 2, and 6/7 of year 3, which might be around 80 something percent. You could put it that way. And so our payback period is expressed as 2 and 6/7 years. Thank you.